Dear friends, have a good day. Here in this video today we are going to look at theorem on convergent sequence. Theorem on convergent and divergent sequences. Have a look at the statement. Question number 1. If 0 less than x less than 1, then the sequence x power n converges to 0. Question number 2. If 1 less than x less than infinity, then the sequence x power n diverges to infinity. Here two cases are given. If x is lies between 0 to 1, then the sequence x power n converges to 0. If x is lies between 1 to infinity, then the sequence x power n diverges to infinity. Let's look at the first one. It has been given that 0 less than x less than 1. Then x power n plus 1 can be written as x into x power n, which is less than that of x power n because x lies between 0 to 1. So x is in the form of 1 by n. That is why x power n plus 1 is less than that of x power n. So the sequence is in the decreasing order. Hence the sequence x power n is monotonically decreasing. So to prove convergence, here what you have to do is the sequence xn is monotonically decreasing and bounded below. Since x power n greater than 0, what you can say is x power n is bounded below because the numbers less than that of 0 are called the lower bound of the sequence x power n. Therefore, the sequence x power n has so many lower bounds. That is why the sequence xn is bounded below. So here note that the sequence xn is monotonically decreasing and bounded below. That is why the sequence x power n is convergent. Therefore, the sequence x power n is convergent. Here note that when a sequence is said to be convergent, if the sequence has a limit L, then the sequence is said to be convergent. So here we have proved that the sequence xn is convergent. Therefore, it has a limit L. So let us take limit n tends to infinity x power n is equal to L. Then by a known theorem, what you can say is limit n tends to infinity x power n plus 1 can be written as limit n tends to infinity x into x power n, that is equal to xl. Because since if limit n tends to infinity Sn is equal to L, then limit n tends to infinity Csn becomes Cl. So that is why if limit n tends to infinity xn is equal to L, then limit n tends to infinity x into x power n can be written as xl. Which means that x power n plus 1 is also converges to xl. But x power n plus 1 is a subsequence of xn. Note that if a sequence converges to L, then its subsequence should also converge to the same limit L. So here x power n plus 1 is a subsequence of xn. Therefore, x power n and x power n plus 1 must also converge to the same limit L. Therefore, both the sequence would converge to the same limit. Hence, we can write L is equal to xl. Now bring this xl into left hand side, then what you get is L minus xl is equal to 0. And then take L outside. What you get is 1 minus x into L is equal to 0, which implies either 1 minus x equal to 0 or L is equal to 0, which implies 1 is equal to x or L is equal to 0. Here note that 1 is equal to x is not possible because it has been given that x lies between 0 to 1. X is less than that of 1. So that is why 1 is equal to x is not acceptable. So that is why here we have taken the condition L is equal to 0. Since x less than 1, x equal to 1 is not possible. Therefore, L is equal to 0. Hence, if 0 less than x less than 1, the sequence x power n converges to 0. And then now come to the second one. Let x greater than 1. Then x power n plus 1 can be written as x into x power n. Since x is greater than 1, so x power n plus 1 is greater than that of xn. From this we can say that the sequence x power n is monotonically increasing. So that the sequence x power n is increasing sequence. Now what we have to prove is the sequence x power n diverges to infinity. So to prove x power n diverges to infinity, it is enough if we show that the sequence x power n is not bounded above. So to show that the sequence x power n is not bounded above, assume the contrary. Suppose that the sequence xn is bounded above. Then by a known theorem, the sequence x power n would converge to L belongs to R. Then as in case 1, we can show that L is equal to Lx, implying that L is equal to 0. Therefore, the sequence x power n converges to 0. Hence, limit n tends to infinity, x power n is equal to 0, which is not possible because the value of x lies between 1 to infinity. So that is why x is greater than 1. So x cannot converge to 0. So this is not acceptable. So what we have assumed is wrong. Therefore, our assumption is wrong. Hence, the sequence xn cannot be a bounded above. So thus we have the sequence xn is monotonically increasing and not bounded above. Therefore, the sequence xn diverges to infinity. Therefore, the sequence xn diverges to infinity when x greater than 1. That's all.